All right, in problem number 16, and allow me to skip number 15. Problem number 16, another logarithm equation to solve for. So we have 2 times log base 3 of x plus 7 and equals to log base 3 of 9 plus 2. Now this equation at first it seems hard. However, take it on the simple side here. Log base 3 of 9, please, you can find the actual answer to that. Okay, log base 3 of 9 automatically equals 2, isn't it? So your equation should be a lot easier than it looks like. So here I have 2 times log base 3 of x plus 7. Like I said, log base 3 of 2 equals 2. And plus 2 again. So you actually have 4, isn't it? So you have 2 times log base 3 of x plus 7 and all that equals 4. And so at this point here, the equation is starting to become clear and more clear. Dividing both sides by 2, I'm going to have log base 3 x plus 7 equals 2. Okay? And so at this point here, perfect. It's in the ordinary form that I can just simply rearrange the 3 quantities I look here. The base, the expressions in there, and the number on the right hand side. So what I have here is, I can do is just simply 3 raised to the square power equals x plus 7, or you can just think of that as x plus 7 equals 9. So picking up from that equation right there, x plus 7 equals 9, subtracting 7 from both sides. The answer is x equals 2. Okay, and once again, please do not rushly circle the answer at this point yet. You need to check your work. Okay, so on the checking step right here, let's see if it worked out. Okay, and we found only one solution so far. We found only one answer. So let's see if that answer really is the solution. I need to plug that equation, that x equals 2, back into the starting equation, which says 2 times log base 3 of x plus 7, but x is now 2, so I have 2 plus 7, and equals 2 log base 3 of 9 plus 2. And let's see if the two sides here are actually the same. Okay? I'm putting question mark on the equal sign once again. So what I'm seeing here is right inside of that logarithm, I have log base 3 of 9 and times 2. And let's see if is it still going to be equals to log base 9 plus 2. Now log base 3 of 9 is 2 plus 2 on the right hand side. On the left hand side we have all that log base 3 of 9 equals 2 times 2. So these two sides are actually equal. So now x equals 2 would be my real answer to the problem, number 16. Okay? Moving over to number 17 on your problem. Now here we're going to start having logarithm terms all over your equations. You're going to have some logarithms on your left hand side and logarithm on your right hand side. So here's number 17. Okay? And please save me some work to say, keep saying solving, but that's just simply the equation here. So I have log base 5, I have x minus 7, okay, and I have plus log base 5 and x minus 4 minus log base 5 of x. Oh, so we still have all the 3 log terms on the left hand side, but let's say, how do we handle all 3 terms of log at once? It's still okay, as long as we have same base. That would be good for us. So now what I can do, that sum right there, according to my rule number 1, you can combine that into one log. So I now have log base 5 of x minus 7 times x minus 4. That's how I turn that into one log. And then still minus log base 5 of x. Okay, equals 1. So now at this point here I reduced to only 2 log terms. And so I can actually reduce further. I can combine the 2 log terms here. And notice I have a subtraction problem. So according to rule number 2 on your log reveal handout I gave out to you, you can simply take the quotient between that whole expression here and the x. So what I'm having is x minus 7 times x minus 4 and all that over x. Okay, I put all that in one quotient. Then I'm taking logarithm base 5. And all that here equals 1 on the right hand side. So now I am in my ordinary form. What I have here is, here's my expressions. Okay, that's the expression. Okay, and here's the base of my log, and there's my number on the other side. There's my number on right side. Okay, so now to solve further in this problem, what you can do is just simply the base, you raise that to the power of 1 and make it equals to x minus 7 times x minus 4 over x on the right hand side. So what I can do here is going to, now to pick up on this equation, I'm going to multiply x to both sides, and I'm going to have 5x equals x minus 7 times x minus 4. Okay, and then of course you need to FOIL this out. You FOIL all this out before you can attempt to solve further. And so I have 5x equals to x squared minus 11x plus 28, and then subtracting 5x over. Okay, and that will give me, so altogether it's x squared minus 60x plus 28. Okay, all that, and equals to 0. And here, once again, you have for yourself a quadratic to solve. And here I can see that, now I'm skipping the solving step for this quadratic in the middle, but I'm going to go directly into my two final answers here. So I found one x, and the other x here will be, let's say, 6, 18, 28. That would be 14 times 2. So it's going to be 14 and 2. Okay, so those are my two answers for this equation. So now, but once again, I'm not going to rushly circle my two answers here yet. I need to check my work. So checking one, what happened here is that, and I think I'm going to have to do this in my other space right here. So when for x equals 14, what I need to do is log base 5 of 14 minus 7, and plus log base 5 of 14 minus 4 minus log base 5 of 14. And let's see if it all equals to, after calculated, is it all going to be equals 1. Okay, so what I can see here is the left hand side, all that here can be equals to log base 5 of 7 plus log base 5 of 10 minus log base 5 of 14. Okay, and so the left hand side, picking it up a little further, I can see that we can do, that can become log base 5 of 70, because I can just simply multiply the two numbers there, put them into one log. Subtract log base 5 of 14, and then here together I can do 70 over 14, because these two, I have a subtraction right there. Okay, so I can do 70 over 14 and taking log base 5, and so altogether 70 over 14, that would give me 5. Okay, so I have log base 5 of 5, and that does equal 1. So now I have my first answer checked. So now I'm going to go back to my solution here and circle my first answer that I found. So let's try with the other solution right here, x equals 2. Let's see if it works. In my equation, in my starting equation, if x equals 2, then this is what's going to happen. The first term is going to be log base 5 of 2 minus 7 is negative 5. Right there, it fails out. Okay, and then the next term, plus log base 5 of 2 minus 4, right there, it fails out again, because 2 minus 4 is going to be negative 2. We cannot take log of a negative number. That's the bottom line. Okay, so now, of course, that's not going to work. So it's not going to be equal to 1, because we don't know what these two terms are going to be. So I'm going to go back to my answer list, and I'm going to take out x equals 2. So x equals 14 is going to be the only solution. Okay? So now, let's see what's going to happen if we have log terms all over the places, as in number 19. Okay? So here we have natural log x minus 5 plus natural log natural log terms all over. So the trick here, bring all possible log terms to one side and leaving either a 0 or just simply a constant on the right hand side. So in here I see no other constant besides these three log terms. So what I'm doing here is I'm subtracting this x minus 14. Right? And here, by the way, we want to solve this one for x. So I would like to subtract natural log of x minus 14 from both sides. And that would now give me something like this. Natural log x minus 5 plus log x plus 2 minus natural log x minus 14 equals to 0. All right. And so now I'm having all three log terms on the one side. Now I can just simply, using the same trick I had in the earlier problems, okay? These two, I can bring them into one log, combine them into one log. So I have natural log of x minus 5 times x plus 2, and then minus log of x minus 14, natural log of x minus 14, all equals 0. And now at this point, I took it down into two separate log terms. So now I can even combine it further. These two expressions, I can now set them up into a fractions, x minus 5 times x plus 2, and you can divide all by x minus 14, and there, with my quotient there, I turn that into, I take natural log of that. So now I combine my two log terms into one log term, and equals 0. And here I am in my ordinary form. Okay, so here's the expression of my ordinary form, the expressions. Okay. Natural log means base e. So my base here would be base e. And the number here is the number on the other hand side. So now the problem becomes simple. You can just simply do e to the 0 equals to x minus 5 times x plus 2 over x minus 14. Okay? And of course, we have learned before, a non-zero number raised to the 0 power is going to be 1. So 1 equals x minus 5 times x plus 2 over x minus 14. Okay? And so in the attempt to solve for this final equation over here, after you arrange all the terms, you can multiply x minus 14 to 1. So you have x minus 14. You multiply x minus 14 to both sides, and you have x minus 14 equals x minus 5 times x plus 2. And once again, you need to FOIL all this out. Okay, you need to FOIL all that out to end up with a quadratic and solve. So what I'm having here is, in my next step, I have x minus 14 equals x squared minus 3x minus 10. Okay, and then adding 14 to both sides. Okay, and subtracting x from both sides, I'm going to end up with my new quadratics to be x squared minus 4x minus 24. Okay, equals 0. And so now with this problem right here, I'm going to find out that my two answers are going to be x. It's not going to be something that we can factor nicely, but the answer is, when you use your quadratic formula, it's going to be 4 plus and minus 16 minus 4 times 1 times negative 24. Over 2. And that's how we can use the quadratic formula. So, and then we need to finally check for this work right here. Okay? And so basically you have two answers. One of them is x equals 4 plus square root 112 over 2, and the other one is 4 minus square root 112 over 2. Okay? There's the two answers. And don't forget that you need to check with your final work here. And it's okay to, when you check your work, it's okay to turn all these numbers here into decimal point value and then evaluate that into your equation. But that's how you're going to solve your equations for logarithm.